In this video clip, we will take a closer look at a visual strategy for problem solving called a tape diagram, and how it applies in addition and subtraction word problems. In this video, you will learn about the read, draw, write process for problem solving, and how the tape diagram can be used as a great visual model to help students represent their thinking when problem solving.
Students are introduced to the read, draw, write process for problem solving. Students first read the problem to understand what the problem is about. Then students reread the problem, trying to represent the problem visually. Students may read and draw and reread some more. Next, students try to write an equation, or equations if it's a multi-step problem, to help them solve the problem. Finally, they write their answer to the problem in the form of a statement. This helps them to make sure that they've answered what the problem is asking of them.
Now we are going to apply the read, draw, write strategy. Let's read this problem together. 20 bunnies sat on the grass. 35 more bunnies hopped there. How many bunnies are on the grass now? Now that I've read the problem once for understanding, I'm going to reread the problem and try to represent the problem using a visual strategy called a tape diagram. A tape diagram is a rectangular model used to help visually represent numbers. Instead of drawing out the 20 bunnies and drawing out 35 more bunnies, students can show this work using a tape diagram. So if I know that one of my parts would be the 20 bunnies, and I know that 35 more bunnies join them, what I don't know is how many total bunnies were on the grass now. So you can see visually on my tape diagram, I have both of the parts. What I don't know is what the total is. So students might write this as a number sentence, 20 plus 35, and they could solve it a variety of ways. They could solve it by counting on, they could solve it by using the standard algorithm, or they could solve this mentally, but they would still come up with 55 as the answer. And going back to what the question was asking, how many bunnies are on the grass now? There are 55 bunnies on the grass now. Let's try another problem. 75 apples were on the table. I ate 14 apples. How many apples are on the table now? So again, I'm going to try to represent my problem using a tape diagram. In this case, I know that the total of apples that I started with was 75 apples. I also know that I ate 14 of them. What I don't know is how many apples are on the table now. So using our visual strategy here, we can see that we know the total, we know one of the parts. What's missing is the other part. So students might write this as 14 plus something is equal to 75. Or students might use their understanding of the relationship between addition and subtraction to do 75 take away 14, and they're trying to solve for that missing part. Students might solve it a variety of ways, but any way they solve it, they still should come up with that the missing part would be 61 apples. And if I were to insert this inside of my tape diagram, this would make sense that 61 plus the 14 is going to give me the number of apples that I started with, which is 75 apples. Let's look at another type of problem. Some bunnies were sitting on the grass. 15 more bunnies hopped there. Then there were 37 bunnies. How many bunnies were on the grass before? Now, this is a slightly different type of problem because we're starting with an unknown. We don't know how many bunnies were first sitting on the grass, but we can still represent it using a tape diagram. So I'm going to start with my tape diagram. And I know that there were some bunnies sitting on the grass, even though I don't know how many there were. I know that there are 15 more bunnies that hopped there. And I also know that after the 15 bunnies hopped there, there were 37 bunnies altogether. So what I need to figure out is how many bunnies were on the grass in the beginning. Using this visual model, we can see that we know the total, we know one of the parts, what's missing is the other part. So again, students might solve this by writing a number sentence using addition, or they might understand the relationship between addition and subtraction. In both cases, they're trying to figure out what that missing part is. So 37, take away 15, would leave us with 22. So if I were to plug that into my tape diagram, 22 bunnies were sitting on the grass, 15 more bunnies hopped there, I would end up with 37 bunnies. So the answer to the question that was being asked is how many bunnies were on the grass before? There were 22 bunnies on the grass before. Now that you have seen some examples of tape diagrams used in addition and subtraction problem-solving scenarios, there are a few things we want you to keep in mind. A tape diagram works as a graphic organizer to help students better understand what a problem is asking of them. A tape diagram is an important visual strategy that students will continue to use as they start to work with multiplication, division, and fractions. In this video, hopefully you learned more about the read, draw, write process for problem solving and how the tape diagram can be used as a great visual model to help students represent their thinking when problem solving.